Thank you for watching my videos. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We will now discuss the solution of a problem that appeared in the question paper CSIR National Eligibility Test held in the month of July 2024. This question is from the section Analysis, and the question is related to the subsequential limits of a sequence. This question is from part C, which is a multiple select question. There can be more than one answer. The question carries 4.75 marks. The question ID is 704064. Right. The given question is, let an n greater than or equal to 1 be a bounded sequence of real numbers such that limit n tends to infinity of an does not exist. That means we have a bounded sequence of real numbers which is not convergent. Let S be the set consisting of L belongs to the set of real numbers such that there exists a subsequence of the sequence an that converges to L. That means S is the set of all subsequential limits of the sequence. Which of the following statements are necessarily true? We are given four options. Option 1, S is the empty set. Option 2, S has exactly one element. Option 3, S has at least two elements. Option 4, S has to be a finite set. So basically the question is, what is the order of S? Right. We will now discuss the solution of the problem in detail. We are given a bounded sequence of real numbers n greater than or equal to 1, and it is further given limit n tends to infinity of an does not exist. That is, the sequence is not a convergent sequence. We are given S is the set of all L belongs to R such that there exists a subsequence of the sequence which converges to L. That means S is the set of all subsequential limits of the sequence n greater than or equal to 1. Agreed. Agreed. Now we call our first option. Option 1, S is the empty set. We recall the famous theorem, that is Bolzano-Weierstrass theorem for sequences. Now it states every bounded sequence of real numbers has a convergent subsequence. Right. Using this, by Bolzano-Weierstrass theorem, the bounded sequence n greater than or equal to 1 has a subsequence converging to A belongs to R. That is, A is the limit of a subsequence of the sequence. Thus, A is a subsequential limit. Therefore, A belongs to S. So, there will be at least one element in S. Therefore, S is not empty. Thus, S is non-empty. Therefore, our option 1 is not true. We move on to the next option. Option 2, S has exactly one element. Right. We'll prove that this is also not true. Now, assume that S has exactly one element, say A. So, now that means the sequence AN has only one convergent subsequence converging to A. Why? Because S has only one element A. Therefore, the sequence AN has only one convergent subsequence converging to A. So, therefore, thus all the subsequents of the sequence AN are convergent and converging to A. Why am I saying all the subsequences? Because it has only one convergent subsequence. Therefore, all the subsequences of the sequence are convergent and converging to A. And most probably you remember this theorem. If all the sequence of a given sequence are convergent and converges to A, then the original sequence AN converges and converges to A, which is a contradiction because your sequence is not convergent. Therefore, the sequence AN greater than or equal to 1 converges to a contradiction to the fact that limit n tends to infinity of AN does not exist. That means your sequence AN is not a convergent sequence. So this contradiction says that our assumption that S has exactly one element is false. Therefore, S has more than one element. Thus, option 2 is not true. Right. We call the option 3. S has at least two elements. We have seen that S is non-empty. In option 2, our discussion says S has more than one element. S has more than one element. Right? So, S is non-empty. N of S greater than 1. Therefore, N of S is greater than or equal to 2. That is, S has at least two elements. Thus, our option 3 is true. Agreed. We move on to the last option, option 4. S has to be a finite set. For this is not so. For this, we give a counter example. Consider the sequence AN, n greater than or equal to 1, where AN is sin n, n belongs to n. Observe that minus 1 less than or equal to sin n less than or equal to 1 for all n belongs to n. Right. Right. This means the sequence AN is a bounded sequence of real numbers. Right. Now, note that sin n takes every value. And what is the range of this sequence that is sin n? That is minus 1 to plus 1 with a closed interval. So, note that sin n takes every value of the interval, closed interval minus 1 to plus 1 infinitely many times. That is, for each A belongs to the range, that is the closed interval minus 1 to plus 1, we have a subsequence AN converging to A. If you have not followed this, we will illustrate by means of the diagram. So this is your sin n curve. Right. And the range is the closed interval minus 1 to plus 1. Now, for each A belongs to the closed interval minus 1 to plus 1, we have a subsequence AN. These are the terms of the subsequence. converging to A. Yes, is also true for any A. So for each A belongs to -1 to +1, the closed interval, we have a subsequence of An converging to A. That means to say each A belongs to -1 to +1 closed interval belongs to S, is a subsequential limit. This implies A belongs to S for all A belongs to the closed interval -1 to +1. Right. That means S is exactly equal to the closed interval -1 to +1, which is an uncountable set. And thereby it is an infinite set. It is not a finite set. So thus S is an uncountable set. Thus S is not a finite set. Therefore, the option 4 is not true. Summarizing all the options, the answer to this question is option 3. That is the detailed discussion of the solution of the given problem from the section analysis, which is related to the subsequential limits of a given sequence, given bounded sequence. It is definitely an easy question. I am sure that you understood the solution of this problem. You have been watching my videos and liking them. If it is so, please like the videos in the channel and share them with your friends and colleagues, and subscribe my channel if you have not already subscribed. I wish you all the best. Thank you.